Thanks for coming. I'm excited to talk to you all today. I'm Mike Donovan. I'm the VP of Product at Docker. Hopefully, I'm pretty sure you all know what Docker is. But Docker, we've always been focused on securing the container ecosystem. The next frontier of that ecosystem is obviously AI, right? I'd probably get fired if I don't talk about AI in some way. But I do try to take a measured approach to AI. And usually even I err on the side of being optimistic about the future, and maybe you will at the end of this. I didn't know the previous speaker would have animals, so I'm really happy that there's a theme. But we did just publish an article on the news stack about, the TLDR of it was that open source is more like free puppies than free beer. And that's because it comes with responsibilities, like a puppy does. Those responsibilities, another name for that is like supply chain security risks. Those things are like dependency drift, unverified components, vulnerable software, malware that you have to deal with, and a lot more. At Docker, we've had a front row seat to a lot of these challenges because containers are how many engineers introduce open source software into their supply chain. It's usually done through Docker Hub, which we see over 20 billion different image pulls per month. That's across over 14 million different images. And this has been fueled by the massive adoption of DevOps and cloud native, microservices, IoT, and more, and now, of course, AI workloads. Now, one of the more famous puppies, if you haven't seen the movie yet, is Crypto in the new Superman, great movie, by the way. The puppy has incredible power, but it also has amplified all the responsibilities of owning a puppy or taking care of a puppy. And I think that AI and agentic applications are the same. They're capable of building wonderful new experiences, but they really do amplify the risks associated with open source. On one hand, I'm comforted by this because although there's some new challenges with AI, a lot of the risks look like your regular old supply chain attacks that we all know how to mitigate and work on every day. And on the other hand, though, we still have a long way to go for all software to follow the best practices when it comes to supply chain security. Some recent examples really highlight this. The first is a Postmark, one of the Postmark MCP server attacks. Postmark is a very popular email delivery service, and this was becoming a widely adopted open source MCP server that basically gave you the Postmark API as an MCP server. It was working well. One day, some malicious code got inserted into the project where it would add a BCC line to every email that was sent so that your data got essentially exfiltrated to somebody's personal email address. This was installed on thousands of machines, running locally. An agent was just sending all those emails somewhere, and usually done with elevated privileges. The other attack that's really interesting is Phantom Raven, and this is a two-parter. The first part was using dynamic dependencies in Node to reference malicious code, and that's usually hidden by most scanners. And then the other part was what was called slop squatting. And so this is where the names of the modules, of the node modules, were given the right names so that an LLM would hallucinate the inclusion of that dependency into its vibe-coded app. And so I look at these attacks and I think, well, it is scary, but it's also kind of the same old supply chain attacks that we've been dealing with, just really amplified in the age of agents and the autonomous nature of them. Now, at Docker, we see these attacks and believe the container ecosystem has a lot of learnings we can apply. Imagine instead of random NPM modules, those MCP servers were secured in a container following best practices of supply chain security. They could benefit from isolation to limit the blast radius of an attack, a minimized attack surface, limiting the vulnerable software in the container, assured build provenance, ideally validated to only come from trusted official sources, a comprehensive SBOM to precisely know what software is being run, and clearly identified vulnerabilities and the exploitable status using VEX. These principles became the foundation of modern supply chain security, not just for containers, but software in general. Nearly all of those supply chain advancements trace back to OpenSSF. Projects like Salsa, all the SBOM frameworks, OpenVex, SigStore, Cosign. These projects and more are why Docker is so excited to partner with the OpenSSF so that we can secure the container ecosystem by default. Now, since I mentioned that agentic and AI workloads amplify the risk, we need to apply best practices at scale, usually in automated ways. And so what do we think this looks like? We think it looks like automating integrity, usually in the CI system, right? CI systems we think need to become a lot more secure by default and have the best practices baked into every artifact that's being built so that SBOMs are generated, provenance is generated, as well as everything, all artifacts being digitally signed. We think that verification has to be automated throughout the SDLC, making sure that only verifiable components are used at each stage, from local to integration all the way into production. And then we think that we have to start really moving towards a continuous scanning and patching process instead of one that's done on a regular schedule, utilizing things like VEX to make sure that you're only securing the things that you have your prioritized list of vulnerabilities to secure.